Today's lesson, we are continuing using technology to display data and find a linear regression. But today's lesson, we'll be using both the graphing calculator and Desmos to create a scatter plot from a set of data. And then we'll derive the line of best fit. And from that, we will find the linear regression equation. So we'll have a set of data. So that's our goal today, to develop a linear regression equation from a table of data and to use the regression equation to solve problems. The first example we'll look at is from your assignment 3. And in this first assignment question, you're given a set of data here, the lakes. There's an area of the lakes, the depth of the lakes. And the next step is to create a scatter plot. And from the scatter plot, you derive the line of best fit. And from the line of best fit, you'll find the linear regression equation. So before I go into the technology piece here, by using the graphing calculator or Desmos, and I have a phone version of it here. The previous lesson I used the iPad. I would like to do a sketch of the graph on the graph paper here before we go to technology, because it gives us a good visual understanding of what is happening before we go into the technology piece. So this will be the area, will be our x value, and this will be our y values or depth. So we can label our horizontal axis or x-axis as area, and this is in kilometers square. And notice it's going up by a huge amount of numbers here. So we can make these into thousands. So we can say this will be, put 3 zeros beside it. So we can actually write that as in, make it 1, it will be kilometers squared. It tells me whatever value I have here, you multiply by 1,000. So I'm going up to 82,100. So I need to have at least 82,000 on my horizontal axis. So this would be 0. Now you can go to any amount you want, but we'll limit it to maybe 100,000. So if we go up by 10, 20,000, would be 10,000, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that will cover the area. So we have here 10, 20, 30, 40, 50,000, 60,000, 70,000, 90, 100. Our y-axis is our depth in meters. Now it goes up to 400. So we probably need a scale of 50 here. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. So we have a pretty good scale here, a range. Now, if you want to extrapolate, it will be very difficult to extrapolate. Sometimes it might be wise to extend this beyond 100, maybe 200,000 kilometers. But for now, we are using the range given the scale here. So the first one is an area of 82,100, 406 meters in depth. So the area of Lake Superior. So we find 82,000, which is approximately around here. Now I'm going to use a ruler to give me a better approximation here. and a depth of 406. So this is around 82. So 406 is around here, just above 400. So that's my first point. Next point is at 59,600, 229. So 59,600 close to 60. And that's 229. 229 approximately here. The next is 57,800, which reached slightly below. So it's around 57,800. And this will go give you a depth of Lake Michigan at 281. So 281, which should be about here. Lake Erie is 25,700 square kilometers. So we have 25,000, which is approximately here. And it's 64 depth. 64 should be about a little bit higher. 50 to 64, maybe about here. Slightly off. And Lake Winnipeg, which is actually the smallest of the lakes indicated here, 24,400 square kilometers, so 24,000, and the depth of 18, which would be about here. Then I'll do a line, construct a line of best fit. So notice I have 1, 2, 3, 4, 5 set of data. So I'll try to go through as many as possible. So this would be here. So this is an approximation. It's a sketch. Now the question asks, use a regression equation. Now we haven't developed a regression equation. So we'll use a graphing calculator or Desmos. We'll use both today to find a regression equation. And we'll actually find the real depth. So this is x. So x is equal to 43,000 kilometers. The question is, what is y? So if x is 43,000, which is about here, y would be around 155 kilometers. So that's our 155 kilometers. Meters in depth. So this is our estimate. We're not sure yet. Now we'll go to our graphing calculator first and show you how to input the set of data into our calculator and derive the linear regression equation, and then we'll find the value for y for the x given here. Now, all of the instructions for the graphing calculator is found in your booklet on page 13. Okay. So you can follow through in your booklet. But let's go to our calculator here first thing. First, I am going to. Now you can reset your calculator. So you can go second, enter, clear second memory, let's reset. Okay, now I have to move up my screen a little bit higher so you can see a full calculator here. Sorry. So I need to reset, but you don't have to do it. I would like to reset my calculator second. And this is in your book, plus sign. And then go down to reset. It's also actually more importantly on this sheet here on calculate instruction for applied math. So I would suggest you use this sheet. Is much more handy, much handier than the one in the textbook or your booklet. So I go second plus sign is 7 for reset. And I press 1 for all, and then reset. This clears up whatever data you have, but you don't have to do it every time, but it's a good practice. But since you have your own, if you have your own calculator, you may not need to do this. Now, the first step, I want to input my data into my calculator. So I go to my Stat button, we'll edit. Now this is L1, and this is L2. So one of the things you have to remember, L1 and L2, your X is L1 and your Y is L2. So now I'll input this data here, exactly. So we have it, 82,100. And we have 59,600. 57,800. And 25,700. Oh, should get that, 57,000, then 25,700. And the last one is 24,400. Make sure these are correct. So 82,100, 59,600, 57,800, 25,700, and 24,400. Now I go to my L2, my 406, enter. Each time you have to touch the enter button. We have 229, 281, 64, and 18. Now we have a set of data. The next step now is turn your stat plot on. Now if I go to my graph, I wouldn't see anything there, but I need to go to my stat plot on. Now this would be beside here. So we set of instructions here. So I've completed this part here. Enter data in your list. I go to my stat plot. So I press my second Y button and press enter. And you want to turn that on. It's on, and press enter again. And that gives me my stat plot. Now I need to change the window. So I go to window. The reason for changing the window is that by default, your calculator gives you a graph between 0 and 10. 0 plus 10, 0 minus 10, or plus 10 or minus 10. But your range, remember your range for your x-axis, sorry, your y-axis, your range here is up to 500. Your domain, which is your x-axis here, goes up to 100,000. So you need a huge value. So we need to set our window here to our x-axis as 100,000. So this is really 100,000 down here. And up here is 500. So my window right now, this here, should go all the way to 100,000. And going up here, we don't need our negative values. So this is where we're going to set our window. So I go to my window button. And where x minimum, you set it as 0, because you don't need a negative. Your x maximum, that is your domain here, which goes up to 100,000. So I'll put it here 100,000. I'll show you for press graph now. It's very extensive, but my y is still 10 positive and 10 negative. So I'll go back to my window and set my y minimum as 0, because that's my y minimum here is 0. My y maximum, I want to be 500. So I'll go up to down next here, press enter, 500. If I do that, I have my window with my data plotted. So this is my scatter plot. So we enter our data into our calculator using your stats. So we have done step 1. So first of all, we reset our calculator, step 1, which you don't need to do every time. It's only when you're sharing calculators you want to reset your calculator. But in your case, if you're just using it for equation of a straight line, you don't need to reset it. But it's not a bad practice to reset it whenever you share a calculator with someone else. Then we enter our data, which we press your stat button, press enter, which we already have here. Next, we go to our second, put our stat plot on, make sure it's on. Next, we go to our window and we set our window according to our domain and range here. And this is one of the reasons why I wanted to do a sketch on paper so you can see the range here. The next now, if you look at this here, we have our scatter plot, but we don't have our equation. Now, if you press your y equals button, you'll see the equation will be here, but there's nothing there. So to get our equation, we go on to the next step here. So determine the linear regression. So now we have our graph, we have sketch. So you have to enter your data, press stat, and then cal. So now we're going to go to press your stat button. Be careful, that's your stat button right here. Press that button. Then you go to calc. You do that by pressing your right arrow button on your calculator here. Now, once you go to calc, there's a menu here of various regressions, equations. We would like to use a linear regression, which is number 4, because that's what we want to find, a linear regression. So we toggle down to number 4, or we can just punch in 4 here. So toggle down to 4, press enter. Now press 4, it says here. Now press down the arrow key. Now press or 5. If you're doing quadratic, the next booklet will be looking at quadratic regression, but this one is not here right now. Now you want to move the arrow down to store REQ, as it mentioned here. Press in the arrow to store reg. So we go to here. Or if it's up here, you press your enter button. Now this is critical because then you press your vars button, which is this button here. So you do the vars button. And then you go to the right arrow key on wise vars and press enter 3 times. So press your vars button and press your right arrow key and go to y vars. Here you'll see function, parametric, 3 polar, 4 on off. You want to leave it there. Don't be, and this we're going to press enter 3 times. 1, 2, 3. And continue one more time. This is your linear regression equation. So y is equal to 0.006 minus 118. So we're going to write that equation down. So we have y is equal to, Now, wherever the a is, replace it with the value for a equals, which is 0.006 x minus 118.65. So this is my linear regression equation. Now, if you were to press your y equals button, you'll find the same equation being displayed with up to 9 decimal places or more. So that's my equation. So for our purposes, we leave it to 3 decimal places and 2 for the b. So this is your y-intercept. So if you were to extend this graph all the way down, it will intersect the y-axis, this one here, at negative 118.65. This refers to the slope. The next lesson, we will be examining the equation of a straight line, what it really means. What it means right now, this is your slope and this is your y-intercept. Now that's hit graph, and there is your line of best fit. Now, I'll just remove this for now. I'll zoom in a little bit here because my graph isn't showing up as well as I would like. Okay. Now there's your line of best fit with our equation given. So here we have our equation. The question now comes up. Okay. The regression equation question is, what is the depth of the lake, of any lake that has an area of 43,000 square kilometers? So what is, when x is equal to 43,000, what is y? Now we have a y of 155 here approximately. So let's see what our calculator would tell us. Now, in your handout, you'll have to go to the second page. We want to find a y value. And here where it says, determine the y value. We give the x value, in this case, the x is equal to 43,000. We want to find a y value. So we'll use this set of instructions. Now here's our graph. This is my x-axis, y-axis. So once we have our equation, y equal to, we have our line of best fit. We follow step 2, second button here, and trace. So second and trace. Then you will hit the enter button. Sorry. And he said, type in whatever x value you were given. The x value we're given is 43,000. So I'm going to put in here 43,000. Then press enter again. That gives me a depth of 155.48. So this is your answer at the bottom of the screen. So that's my depth when the area of a lake is 43,000 square kilometers. So is it almost the same? Pretty close. Our estimate, 155, and oops. And our calculator gives us 155.48. By the way, where it's flashing here, that's the point x 43,000, y 155.48. So we can conclude, we'll change this guy here. Since 155, we can remove that and put decimals here. So 155.48 meters. That's using your graphing calculator. Okay. Now we're going to go into Desmos and do the same thing. Okay. So you can use your phone. You can go to the same thing. I install the Desmos app, and you can do the same thing. Or if not, you can just go to your search in your phone and put Desmos. And you go Desmos calculator. A slightly different interface compared to the iPad or the computer, but because it's a smaller device. So our next step is to input our data. Let's move this here so we can have a better. Okay, now we need to create a table. And to create a table, we hit the plus sign here. So the first step, now by the way, all of these instructions are in a handout. So we'll go here, first thing we go to Desmos. And the upper left side, click the plus sign, which you just did. And you have, this appears. Next, we want to click the table. So you want to go to table here. So we'll have this chart comes up. And the next step, you're going to enter your data. Okay. So our data we're going to enter here is the one given for the depth of the lake. So let's put that in here. It'll be a little bit tricky here. So first one is 82,100. As you can see, this is a little bit more challenging for the phone, but it does the same work. So 59,600. Press enter. Then we have 57,800. Enter. 25,700. And the last one is 24,400. Now, this is our set of data: 82,100, 59,600, 57,800, 25,700, and the final one, 24,400. Now we need to enter our Y values. First one is 406. Enter. 229. 281. 64. And 18. There's our set of data. Now, this is our graph up here. We see nothing so far. Okay. There's no scatter plot here. To see our scatter plot, hit this plus sign here. Oops. And there is our points. It's very similar to what we already have here. The same as what we had on the graphing calculator. Now we need a line of best fit and our linear regression equation. And this is where, now once we've done that, we need to input into line 2 y tilde mx1. Be careful with this one here. It has to be x1 and y1. Okay, so we'll do that right now. We're going to put in this box here, y. Now, the keypad comes up, so it helps here, y. Now, the tilde sign, you need to press your A, B, C, and the tilde is right B there. But before that, I need to put 1 there. I need a subscript. I need that 1 mentioned there. Has to be part of it. Then we go to our tilde sign. We have mx1, so m, x back to 1. So on the best now plus, we need our b. And that is our line of best fit. Notice my equation now is similar to what we had now. Let's go back to what we have. Y is equal to point. Now, m is 0.0063, so 0.006. And y is negative 118.65. So we have the exact value as the graphing calculator for our regression equation. So this is our regression equation. So you have to read it off here. Now, the R means correlation coefficient. We don't need that right now. This is telling us how closely related the set of data here. Now, the area of the lake and the depth of the lake are related. It's a strong correlation. Now, my next step now is to find out what is the value of y when I know my x. Now, this is, and if you can touch any one of those variables, you'll have the same thing. Now I need to go to my next line here, line 3, and let x be 43,000. So we got x, go back to this button here, x equal to 43000. And there is our line here, represents the x equal 43,000. So if we were to touch that, that gives us a depth of 155.48 meters, which is exactly what we got in our graphing calculator. So either way, you'll end up with the same result, graphing calculator or Desmos. Okay. So that's question example 1 in your textbook. So let's go over again. So our goal is to develop our linear regression equation from a set of table of values, and to use that regression equation to solve problems. We use Desmos, and we use the graphing calculator. To get the same result. And the instructions for the graphing calculator are on a sheet that you're given, along with a handout and how to display data and find the best fit. There's also a video tutorial below this video using both of these. They're generic. The next lesson, I'll be looking at the next example question. and determine the regression equation for a make of car. So this will be our next lesson, along with, and so you're, for now, I would like you to attempt this question using either the graphic calculator or Desmos. The third question, it's a quadratic, which we will be doing, this will be done in booklet number 4. So you can skip this one for now. But also, I would like you to try example 4. And the last one is example 5. So your task is to complete, or at least attempt, question 2, question 4, and question 5, in your assignment 3 booklet.